Hey guys, welcome back to math class. Today we are going to dive into probability and look at simple events. And I really hope that the title alone puts you at ease. We're going to try to make this simple. All right. So, simple events is very much going to look just like what we did with probability, with the probability lesson. We just need to kind of define it a little more. So, a simple event is one event with one outcome. Now, that outcome might be multiple things, but I'm only going to do it once. So, like, I'm going to reach into my bucket of markers and I would be happy with, let's see, I've got purples and blues. I would be happy with a yellow or an orange. So, if I reach over here and I pull out a yellow, let's pretend it was random. Um, this is one event, but I would have been happy with orange. So, I would look at all of my yellows and oranges, and either one would be fine. So, one event, I'm going to pick one marker. I'm going to end up with one marker. Now, some very common examples of simple events are flipping a coin. Like one time, flip a coin. If you roll a number cube. And then one of my favorite ones is draw a card. Now, if you are not familiar with a deck of cards, you might want to get that way because you might see several questions about those. So, just like when we talked about probability in the intro lesson, simple events are when we compare what we want to happen to total possible outcomes. Total possible outcomes. So, like with a coin, how many sides of a coin are there? There's two. So, these are my outcomes possible. And rolling a number cube. How many sides are there on a cube? 6. And drawing a card. This one you might not know. There are 52 cards in a deck. 52 cards in a deck. So when I'm comparing what I want to know versus the total outcomes, I'm writing it as a fraction. I do want to simplify it. We always want to write it in simplest form. Still going to be written the same with the P for probability. So, what is the probability of getting a black card? Now, again, if you don't know much about cards, half of the deck is black, half of the deck is red. So, but total wise, how many black cards are there if there's 52 total cards? There's 26. So there are 26 black cards out of how many total cards? 52. And then I would want to reduce this to its simplest form. I know that I can reduce both of these by 30, 26 actually. It's divided by 26 because I know the answer is 1/2. So if I randomly draw a card out of a deck of cards, 1 in 2 of those, I have a 1 in 2 chance of getting a black card. Now, what about probability of getting a specific card? So let's say, what is the probability of getting an ace? If you don't know, there are 4 aces in a deck. Out of how many total cards again? 52 total. And I need to reduce this. What could I reduce this by? 4. And that would be 1 out of 13. So there's a 1 in 13 chance that if I randomly pick a card out of a deck, that it's going to be an ace. And now the more specific you get, the less likely it is to happen. So if I wanted to get ace of spades, so the probability of getting ace of spades, there's only one of those out of 52. So that's kind of what probability looks like. Now, you might see the words or, because I might be happy with, I don't know, ors. So, what is the probability of getting a, let's say, an ace or a 10? I went blank on what the cards were. An ace or a 10. So, when I see or, we add the two outcomes together because I would be happy with either. So, how many aces are there? 4. How many 10s are there? There's 4. I'm going to get to. So, I add those together. So, there are 8 cards that I would be happy getting out of 52 total. And then I would simplify it. So, when you see or, we would be happy with either or. So, you want to add those possibilities together. Now, the next thing we need to talk about is a little vocab. Theoretical versus experimental. When you are dealing with theoretical, we talked about this last lesson, theoretical probability is La La Land. This is a perfect world. It's La La Land. It's in your head. It's not real, but like we're going to pretend it's real. I always liked to use the example like when you see in movies that some guy is watching the girl sleep and like in theory that's like, "Oh, that's so romantic. It's cute. He's watching her sleep at night." But like in reality, that is scary, man. Like, no. Don't watch me sleep. Like that's creepy and weird. So theoretically, it works in movies and TV shows and in books and whatever, but that is La La Land. That is not reality. So when we're dealing with theoretical probability, it's perfect world scenarios. The other end of that is experimental. Experimental probability, they are going to give you information. And all you have to do is write it as a fraction. So let's say I flipped a coin. I wrote it down. I flipped a coin 24 times. 24 times. Flipped 24 times. Landed on heads 13 times. And so it might ask, okay, so what's the probability of landing on heads based on this experimental data? So you would take the 13 because I wanted it to land on heads and then over the total, and then you would reduce it if you can. The experimental part is probably going to seem very easy, and you may even think you're doing it wrong, but I believe in you. All right, go forth and do probability. I will see you guys next time when we talk compound.